Welcome. In this series of short videos, we will look at topics for the PowerBasic Console Compiler. Today we will look at profiling your first processing project using the Console Compiler. This was our console application at the end of the last video. We have created an application that will do some processing for us. It will generate 90 days worth of information, taking the current date and working back 90 days, and outputting to a CSV file all the days which are between Monday and Friday. The application starts by writing to a log file. This log file will contain the start and the end times of the application. This will allow us to see how long the application took to run. In the middle of our application is the processing. And at the end of our application, we wait 8 seconds and then exit the application. If we run the application now, you'll see it runs quite happily and it exits the application after a number of seconds. If we have a look in its log file, if we open that up, we'll see that the application started at 50 seconds past 13:20. And it finished at 59 seconds past 13:20. So the application ran for a total of 9 seconds. As we saw at the end of the application, we wait for 8 seconds before exiting. So the actual processing only took 1 second. So on the whole, the application is pretty efficient. One thing which you should do during the development of your application is to ensure that it stays as efficient as possible. And that's what we're going to look at today. We're going to be looking at the profile command. But first, we're going to make a few changes to the application as it stands to make this profiling a little easier. First of all, we're going to reduce the exit timing from 8 seconds to 3. Normally, your console applications will probably run in the background. There'll be nobody watching them. Therefore, you probably don't have to keep them on screen after the application completes for very long at all. Most of these delays are useful just for development. So the first change I want to make is to store the name of our output file in a constant at the beginning of the application. And in addition to that, I'm going to increase the number of processing days from 90 to 900. And we'll change the name of our output file to output daylist. And just to ensure that this file would not be lying around on the computer before we start running, we're going to put an additional kill command in to wipe out that file should it exist. And there is our additional kill command. This is encapsulated in a try-catch block. So if the file exists, it will be deleted. If the file does not exist, it will not generate an error. And in here, where we are setting the name of our output file, we'll replace that with the name of the constant. So within our PB main function, we have a call to an external function called process. This performs all our processing. And we'll have a look at the process function. The process function does some settings on the console, and then it starts doing the processing. The processing is all done in memory by adding to an array called days. After all the processing is completed, it will then attempt to output the array to a file. Since we're going to be profiling this application, I'm going to break the processing function into two. The first part will do the actual processing, and we will do the saving of the array to a file in a separate function. So this section here, we're going to split off to a new function. So we will delete this section here, and we're going to put that into a new function. And we're going to call that function saveArray. And my intention is that the saveArray function will take 3 parameters. The name of the file we wish to output to, the array containing the data we wish to output, and an error variable. If there is any problem saving the array to file, then the error name will be saved into this variable. So if the saveArray function saves successfully, we will get a return of true. If it returns false, then we can print out to our console that we are unable to save the file. So we're using a new variable here called error, so we're going to have to declare that at the beginning of this function. So let's now go and create this new save array function. So here is the skeleton of our save array function, taking its three parameters: the output file name, the pointer to our array containing the day's information, and a return variable which will contain any error should one occur. As before, we're doing exactly the same thing. We're defining an output file handle, populating that using the free file command, and within a try-catch block, we're going to attempt to write to our file. We're using the clear command to clear out any existing errors. Then should an error occur, we will jump to the catch section of the try-catch block, and we will use the error $command with error as its single parameter to pick up the error string, allowing us to display that to our user and into our log. So this section has not changed functionality, and our application compiles quite happily. If we attempt to run the application now, it says it's saved the file successfully, so if we have a look on our file, we should see we now have a new output daylist CSV file, which has just been created, and it will contain 900 records. So our application is working fine. What we're going to do now is use the profile command. So let's go back to the pb main function. In our pb main function, if you go down to the bottom just before we exit that function, and in here we're going to put our profile command. And there is the profile command. The profile command has a single parameter, and this is the path and the name to the file into which you want to put the profile. As we've put no pathing in, it will save it to the current folder. So if we run the application once more, it will run quite normally. It will take its 3 seconds and it will exit. So if we go back to the folder, we'll see we now have a profile.txt file. If we open that up, we'll see we have a file with 3 columns. The first column is the name of the function or subroutine. The second column is the number of calls made to that function. And the final column is the length of time that we spent within that function, described in milliseconds. So we can see in here we spent 10 milliseconds inside the save array function. And in our process function, we spent 273 milliseconds. And as expected, since we're waiting for 3 seconds before exiting the application, we spent just over 3000 milliseconds on that function. So this gives us a baseline. Taking 273 milliseconds for the kernel processing of our application is quite good. However, what if our application was not as efficient as it is currently? Let's make it a little less efficient. Once more, back to the code. In our processing function, we do the calculation within a loop, and we're populating information within this array. And after we've got all the information into the array, we then dump the information that's in that array out to a file at one go. What if we change this to save it to the file as we went? We are already making use of a function called append to a file, which takes a file and a string and writes that string to the file. Or if we use this function to write to the file as we calculated the data. If we're going to do that, the very first thing we need to do is open the file and write our headers to it. So here we have the append to file call, outputting to our output file and sending the date and the day of week column headers out to our file. Then we can get into our while loop. And for the moment, we will comment out this section of code which saves the array. And rather than saving it at the end of the while loop, we're going to save it as we go. So after we have calculated the date string and the day of week string, we're going to send that out to our file and append it to the file that we're building up one row at a time. Should any error occur, we're exiting out of our loop. And since we have commented out the saveArray function, that will not be executed. So before we exit this function, we'll need to return the value true if it has been successful. If it has not been successful, the error variable will have something in it, so we can actually test that. So we test the value of the error variable. If it is currently blank, then the saving to the file must have been working correctly. We can then return the value true to the calling function. So if we try running our application now, we will see it is now processing, but to the eye it's certainly taking longer to process than before. But processing has been successful. So if we go back to our folder, we can see that our output day list has been populated, and it does indeed have 900 records in it. So our application is functionally the same. It's taking the same inputs and producing the same outputs. Let's have a look at our profile. So as we can see from our profile, we are spending 4,718 milliseconds in the process function. Now, as it's calling the append to file within that function, that's the one that's taking the greatest hit. It has been called 903 times. So we can see the processing time has been radically increased. The exit application function is still taking around 3 seconds to run. So the append to file is a lot less efficient than our method before. The reason for this is the append to file function is opening the file, writing one line of data to it, and then closing the file again. So we're doing a lot of opening and closing of files, namely 900 of them. Previously, when we were dumping the entire array out to the file at one go, we only opened the file once, wrote 900 lines of data, and then closed the file. So we can now see the difference using our profile command between the two approaches. Both produce exactly the same output, but opening the file once, writing the data and closing the file is the more efficient method. And this is a good use of the profile command to see which of your subroutines is taking the longest to run. The profile command is of course only supposed to be in your application during development. Once you have your application completed and running as expected, you can then remove the profile line of code, as this is only needed during your debugging. So in summary, what we've done today is we've broken the application down to smaller functions, taking the saving functionality and putting it into its own function. This allowed us to use the profile command to identify which of the functions or subroutines in our application was taking the longest time to process, and which was called most often. This approach can be used to make your applications as efficient as possible. While an individual function or subroutine may run very quickly, if you're calling it 1 or 2 million times, the numbers do add up. Hopefully you'll find these techniques useful in your own applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.